All right, Algebra 2, Section 4.3, Modeling with Quadratic Functions. All right, so this one is a little bit easy and hard at the same time, in that we're going to find the coefficients for quadratics. So here we have a situation where they want us to find the equation for a quadratic given 3 points. And the reason why we have 3 points is because we have 3 unknowns. We have the coefficient in front of the x value, the coefficient in front of the b value, and then the constant c. So a quadratic equation is in the form of y equals ax squared plus bx plus c. We don't know what the a, b, or the c is. We don't have no clue. A, b, and c. So in order for us to solve, we have to have 3 separate equations, systemic equations. And the reason why we need 3, because we have 3 unknowns. For every unknown that you have, which is in this case a, b, and c, we need 3 equations so we can solve for each one, essentially one at a time. So in the first got it, they give us 3 points. They give us 0, 0. They give us 1 and negative 2. And they give us negative 1 and negative 4. Alright, like I said, this is going to be done in 3 parts. The fact that they give us 0, 0 is really, really good. So what we're going to do is we're going to place in 0 for x to get our y, which is 0. So we've used the first point. Matter of fact, let me color these. 0, 0. And I make this blue. I think that'll come in handy. Okay. We plug in 0 for y. We plug in 0 for x. A times 0 squared. We plug in 0 for x over here with the b. And then we're looking for a c. Since the fact we have 0, 0 is extremely convenient, because then all of this is just 0 equals 0 plus c, and then our c is equal to 0. So we have no constant, which is really good. So we know that c is 0. So I'll call this step 1. Okay, step 2. We have this 1 and negative 2, so we're going to substitute negative 2 for y. And anywhere we see an x, we're going to substitute 1. We know that our c is 0, so we're going to say plus 0 or just leave it alone. We don't need a c term. So doing the math, this is negative 2 equals 1 squared is 1 times a is a, 1 times b is b, a plus b. Then our third step is we plug in these guys, so that's negative 4 equals, and we're going to plug in negative 1 for x, and we don't have a c term, so it's going to be 4 equals a minus b. So look what we have here. We have, and let's call these equations number 1. Let's call this equation number 2. Let's call this equation number 3. If we look at equation number 3 and 2, they're pretty much almost sort of identical. I mean, the negative 2 and the 4 is different. The a is the same, and the b and the negative b are different. They're opposite signs. There's a plus b and a negative b. So I can add these equations together. I can add these equations together. So I'm going to add equation 2 plus equation 3. And that's going to be negative 2 equals a plus b. We're adding, and I'll put this in parentheses. 4 equals a minus b. And the reason why I'm adding is because since these two are opposite signs, I can eliminate them. And I can just have one variable. I need to solve for one variable at a time. So this gives me 2. This gives me a. So my a is equal to 2. So we have two of them right now. We have a is equal to 1, or 0. Yeah. A is equal to 2 and c is equal to 0. So now we just need to find our third variable, b. So what I can do is I can pick any of my equations. I really wouldn't want to do equation 1 because it's c equals 0, but I can choose 2 or 3. To find my b, I'll choose equation number 2. That's the one I will use. So this is step 4. And I'm going to use equation number 2. And then since I know what a is, I can substitute 2 for a. So this is going to be negative 2 equals 2 plus b. And then I'm going to subtract 2 from both sides. And I'm going to get that b is equal to negative 4. Alright, so now I have my 4 coefficients. I have c, which is 0. I have 2, which is a. And I have 4, which is b. And I put them into this equation, right? So this is 2, this is negative 4, and this is 0. So it's going to be y is equal to 2x squared minus 4x. And then I don't have a 0, I have a c, so it's done. That would be my equation. Of course, in this Got It, they sort of give you the basic example, and they eliminated the c for you by making it 0, 0. That is not always going to be the case, and we'll talk about that in a second. Here, using sort of a graph, you can do that to extrapolate the vertex. And remember, the vertex is either your maximum or minimum of your parabola. And remember that the vertex in standard form is equal to the negative b over 2a, and then f of negative b over 2a. In vertex form, it's considered hk, if you recall. Okay, so if you are given a parabola with an equation, what you can do is you can find the vertex by substituting the negative b over 2a. So here, they give us an equation of negative 16 2 squared plus 150 plus 1, so it's a downward facing parabola. So your vertex is going to be your maximum point. Since we know that we can get the vertex by doing negative b over 2a, we would plug that in, which is what they do here, and they get the k for it, which is 150. So your be like around here somewhere. And that would give you your vertex points. And that would give you your maximum according to the graph. and the maximum that I give is 352. So that would be the height of your parabola. And this 4.7 is sort of the area of, oh, I wonder if this is the right graph. I guess so. Would be, no. This is just some random picture. It don't look right. Of the graph. So this would be the x of your maximum, this would be your maximum. Don't care about who stayed longer, but if you care, you just look at the x times and see which one stayed longer in the air. So there's two roots, so you have to do where x is 0 and you will find your y, that value. So it's 0, 12. So you just have to find out the 0. Just more of the graph. Quadratic regression. That's a graphing calculator feature. We're not really going to tap into that, so you don't have to worry about that.